Hello and welcome to the Prevent Blindness Ohio online adult vision screening training program. My name is Bridget Cruz and I'm a certified adult vision screener trainer with Prevent Blindness Ohio. Prevent Blindness is a national organization with chapters in different states. The chapter within Ohio is called Prevent Blindness Ohio. Prevent Blindness Ohio is a 501c3 nonprofit organization whose main goal is to prevent blindness and to preserve sight. Our main objectives for today are to provide you an overview of common age-related eye diseases, to explain the purpose of a vision screening, to discuss all the components of a vision screening, and to teach you how to interpret the results and determine who needs to be referred. The most common causes of blindness are macular degeneration, glaucoma, cataract, and diabetic retinopathy. Various groups in the population are affected differently by these diseases. Caucasians have more blinding from macular degeneration than African Americans, whereas African Americans are blinded by glaucoma more frequently than Caucasians. Since these are the most common causes for blindness, we will only focus on these eye diseases today. Before we go into detail about the different diseases, I want to give you a brief overview of some of the structures in the eye that will be relevant later on when I talk about the specific diseases. As a whole, the eye gathers in light rays and focuses them as a sharp image on the retina. So the eye is like a camera because it is constantly registering new images and transmitting that information in the form of nerve impulses to the brain. The brain receives these impulses and assembles them into an image and makes sense of these images. The pupil controls how much light gets into the eye. The lens works much like a lens on a camera. It focuses the light rays onto the retina. The retina is the lining of the back of the eye made up of specialized cells that collect images of what we are looking at. So the retina is like camera film because it holds and collects the image. The outer part of the retina is responsible for peripheral vision, while the center portion, called the macula, is responsible for central vision, color vision, and providing fine detail and the ability to read. Any disease that affects the macula reduces central vision. The images directed onto the retina are sent along to the brain where it is processed like developing a camera film. So the optic nerve is like a telephone pole. It sends nerve impulses from the eye to the brain. Or if we're using the camera analogy, the optic nerve sends the images to the brain to get developed.
The location of the eyes enables us to see length, width, depth, and distance of an object. The eye has three layers: the sclera, choroid, and retina. The sclera is the outer white layer that maintains the shape of the eye. Muscles attached to the sclera control eye movements. Choroid is the middle layer that contains the blood vessels. The cornea is a clear circular area in the sclera where light enters the eye. The pupil is the circular opening in the front of the choroid. The iris is the colored smooth muscle surrounding the pupil, which adjusts the size of the opening according to the brightness of light. The lens is located behind the pupil and between the anterior and posterior chambers. The lens is a transparent, flexible biconvex structure that bends or refracts light rays, so they focus on the nerve cells of the retina. The chambers are filled with a watery fluid that gives shape to the eye and helps refract the light rays. The anterior fluid is called the aqueous humor, and the posterior fluid is called the vitreous humor. The retina is the inner layer and contains the nerve cells, the rods and cones, and the bipolar cells. Rods are sensitive to light but do not sense color. Cones sense color. The highest concentration of cones is in the fovea centralis. The rods and cones synapse with bipolar cells, which then synapse with the ganglia cells whose axons form the optic nerve. Light rays enter the eye through the cornea, pupil, and lens, where the light rays are bent or refracted to focus them on the rods and cones, which transmit the stimulus to the optic nerve and then to the occipital lobe of the brain for interpretation.